Okay. Oh, here we go. Okay. Good morning, good afternoon, good evening, depending upon your time zone and when you're listening to this. Excuse me. My name is Seth Early, and I'm CEO and founder of Early Information Science. We have been around for over 30 years, almost 30 years. I hate to say that it dates myself, but we work across industries, and our claim to fame is making information more usable, more findable, and more valuable. A number of years ago, I wrote an article called "There's No AI Without IA," and that was back in 2016. And somebody recently posted that to LinkedIn saying this article is more relevant today than it was then. I coined that phrase, "There's no artificial intelligence without information architecture," saying that at the core of any AI initiative is a foundational architecture, and you can't ignore that. And if people say you don't need that, then that's because those decisions have been made for you. So someone had already built an architecture for the application. Today, I'm going to talk about personalization and looking at personalization from a couple of different perspectives. Now, I had to cut way back on my slides. I originally thought I had an hour. So I'm going to try to hit the high points, but there's a lot more material behind this. And I'd be happy to go through a more extended session if some of the ideas really resonate with you. But we're going to talk about personalization at scale. We'll talk about reading digital body language. What does that mean? That's just like you read the body language of a person if you're talking to them, and you might, if you're a salesperson, might read their body language. And I have some examples. We get signals from when individuals, customers and prospects are coming to our digital applications, our websites or mobile apps, and they're throwing off data. They're throwing off signals. And we can harvest those signals throughout that customer journey and be able to then anticipate and present content that's relevant to their particular needs. So there's digital body language, which is, or the click-throughs, the navigational paths, the searches that they do, what stuff they put in their shopping carts, and so on. Seems like I still have an application open. Apologies for the background notifications. I thought I shut everything down. So, the problem with personalization is it's been around for a long time. It's been promised for a long time. And yet it's still not what it could be or should be. And so to get things right, to get personalization right, we need to really understand the customer in great detail. And really that's understanding their journey and where they are in their journey. And we need to represent that. That's monitoring that digital body language, as I mentioned. We need to read that digital body language, and then we have to respond with appropriate content and information and products that align with their needs, with their mental model of how they solve the problem. How do they think about that problem? How do they go about solving it? What do they do? What do they, what concepts do they think of, right? So we need to deconstruct that journey in great detail. And we call that a high fidelity journey model. Like a journey model is great, but it doesn't necessarily put things in terms that your systems and your technology can respond to. They're great for insights. They give you nice visualizations, but they're really something that your system can't respond to because your systems respond to data and metadata. So you can actually build a journey model that monitors that real-time digital body language and respond appropriately. And again, the mental model is important because a procurement manager is going to have a different set of needs than a design engineer, for example, if it's in a B2B technical space, right? The procurement manager cares about the life cycle of the product and long-term value and so on. The design engineer wants to solve the problems today, needs certain specifications and so on. Those different mental models require different attributes and require different treatment as they go through that journey. And I'm going to give you one example that does this with search. Now, at the end of the day, we have to have the digital machinery to orchestrate this at scale, right? We can't handcraft all of these experiences. We start out with kind of a custom or a crafted type of journey, but then we have to build and configure the machinery and the data structure and the infrastructure, information architecture to support scaling this. So it's not done through acts of heroics. It's done through the actual machinery of your digital platforms. And of course, having clean and consistent and harmonized data, complete data is really important across those channels and across those touch points. And so that's a big area where our knowledge graphs can help us. So when we want to do this, I mentioned detailed journey models. I mentioned high fidelity journey models that describe the audience goals based on their stage, based on their buying stage. And we can kind of look at, well, are they looking at middle of the funnel content, top of the funnel content, bottom of the funnel content? That's coming from human judgment and product managers and so on. But we also have to tag that content with the attributes of the user to understand their role and understand their preferences and understand what they're looking for. We also need an audience model. And again, this is kind of related to the journey model that describes their intent in data terms, right? We don't want a pre-coordinated set of identifiers or attributes like, CIOs in the Midwest in the market for routers. We want three separate orthogonal facets: role, region, intent, or goal, right? Those, because a lot of times you'll see people kind of smushing together all those possible combinations. And that's not tenable, because we have very complex customer attribute models, and that comes from an identity graph, a customer identity graph. We also need the product data models aligned with what's important to the user. As I mentioned before, the procurement manager is going to care about things, different things than the design engineer, than the maintenance engineer, for example. And we need a messaging architecture that's going to allow us to recombine elements. So if we have a page and it has a hero image and it has a value proposition and a call to action and a target user, target persona, well, we can shift those things in and out, right? We can have a different hero image, a different call to action, a different value proposition, a different target. That's a messaging architecture. And think of it like Lego blocks that you're interchanging, or think of it as Mad Libs when you used to play when you were a kid, where you put in an adjective or put in a noun or put in a verb, and then you'd end up with this crazy thing. But you have the structure of the story, and that's what we have to have, is a structure of the story, so we can recombine components and then use machine learning algorithms to optimize based on a goal, based on an objective of greater conversions or greater downloads or whatever it might be. So the idea here is that we have to build that information architecture to support the messaging, the components themselves. So the content has to be componentized, and componentized content is going to serve you in lots of different ways. Not sure if I can get into that in this session, but again, there's some other materials that we have that we can share with you. And of course, we need knowledge and insights up and down the food chain about the customer problems and about your solutions. And this is kind of how it looks, because when you think about product development, whether you're manufacturing a product or procuring a product for distribution, you have product development, and then at the same time, you're doing things in parallel. You're doing market planning and promotion. You're doing demand generation. And so product onboarding is product catalog operations. So while you're trying to onboard the product with certain data characteristics and attributes, you're also building materials. You're building demand gen materials, support content. You're getting feedback from the marketplace. You're looking at promotions. You're integrating your content into a content strategy. You're provisioning customer self-service. You're provisioning field service. You're provisioning the call center. So you have all of these different work streams going on, and all of these different parallel flows of information. And each one of these entities, each one of these individuals, each one of these processes needs a reference architecture. So we have to have maturity in content optimization. We have to have maturity in product information management. We have to have that deep understanding of the customer journey. And we need to have that knowledge and insights from the experts in the organization and collaborate up and down that food chain. Then you can have personalization, right? Personalization isn't something that, is an add-on product. It's a combination of the signals and the information from a lot of these different sources. So this requires, again, maturity in each of these areas: customer experience, content optimization or operations, product data, and knowledge process. Now, there's a maturity model behind each of these, and it gets subsumed into an orchestration model. But we also have to have metrics and governance. And you know, my prior version of the deck had this in a larger slide, kind of walking through the animations. But at the bottom, you have the data and the content and the knowledge. Then that knowledge and data and content supports a process. It supports a business process. We can measure the quality of the data. We can measure the completeness of the data. We can measure the fitness to purpose of knowledge. And then we have, again, process metrics that we can measure to say, well, what is the data supporting? Because data supports a process. Then process, of course, is supporting a business objective or business outcome. So we can have process scorecards and we can have outcome scorecards, and that all aligns with the organizational strategy. And you can do this across the entire customer lifecycle. But let me focus in on search, because search is an important area, right? Search looks a lot like navigation sometimes when we're filtering and faceting. Many times behind the scenes, we may see a piece of information, but it's powered by search. It's surfaced by search. So search-based applications and search is anticipating something that the customer needs based, again, on that digital body language. So, you know, search processes a signal and responds with a recommended result. And this is based on not just the search phrase, but also other factors: who they are, what their level of experience is, what products they own. And the same thing happens with a chatbot. Chatbot is just a channel. I have a continuum that shows search on one end of the spectrum and virtual assistants on the other end of the spectrum, and knowledge portals in between, and simple bots along that continuum. And it's just increasing levels of sophistication of the information architecture and of the capabilities of the technologies, right? But at the end of the day, it's a signal and it's a response. And in a chatbot, we process those signals. They're called utterances, and we resolve into what's called an intent. And then that intent is a trigger to retrieve information. So search, chatbots, all of these things operate with the same basic focused principles, although the mechanisms are very different. And I like to say search terms are short, they're ambiguous, and an approximation of the searcher's real information needs. So again, even when we're doing this with chatbots or ChatGPT, many times people are asking ambiguous questions, and they talk about the prompt and prompt engineering. Prompt engineering is asking good questions, right? Is giving the LLM enough signals to say, this is what I really want. So the more you tell it, the better it's going to answer the question. But again, if we just look at it as a simple utterance or a simple search term, they're very ambiguous in many cases. And so we need a conversation. And this happens again with ChatGPT, right? It'll ask you ask it a question, it'll respond, then you tend to ask another question. But when a query is processed in traditional search, you'll get a list of filters and refiners. What are those? Those are clarifying questions, right? They're asking for additional clarification. I need a tool. Well, what kind of tool do you need, right? Imagine walking up to a counter in a hardware store and saying, tools. The clerk is saying, okay, well, what kind of tools are you interested in? Again, same principle applies to large language models. You can't give it ambiguous queries and prompts and expect a very precise, specific result. So here's an example: tools. And again, this is what I get back in my search refiners. What kind of tools do you want? Do you want tool storage, power tools, air compressor tools, power tool accessories, hand tools, fastening tools, etc. So again, this is a conversation. So other signals can inform that conversation. If a guy comes in and his hat says Joe's Painting, and he says, I'm looking for supplies, one can infer that he wants, painting supplies, right? So the signals that the person provides informs that next stage of that conversation. In this case, it was the appearance. It was their physical body language, right? But again, here's supplies based on your appearance. My guess is you need painting supplies, right? Because you're wearing a painting hat. So in the digital world, digital body in the online world, digital body language is represented by metadata. Every touch point, every tool, every app, every place that we interact with a customer produces data about that user. And we capture those details in a customer identity graph. So digital body language is metadata. It's represented by metadata. And that metadata becomes a signal. In this case, I'm going to talk about search, that the search engine can use to personalize the interaction and personalize the result. So here's an example. If I look for mold stripping, well, does that mean I'm looking to strip mold, strip paint from a molding in a house, right? That could be it. Or I could be stripping, molding on a ceiling, right? Or I could strip mold from the house, like I could say, oh, that's mold and mildew mold. Or I might be looking to strip down an injection mold and need mold release agents. So here, a knowledge graph, an identity graph, is going to tell me what industry they're in, what role they're in, what interests they may have, what processes they're looking at, what tasks. And this, again, the prior version had the actual knowledge graph that represented this. Maybe I have it here. No, I don't have it here. But the idea is that these signals, who that customer is, what we know about them, their identity graph, those signals that we harvest from all of those touch points inform what type of result we're going to give them. And so in this case, again, we have service history, we have the role, we have campaign response, industries, demographics, interests, products. What are those things? What's all that digital body language that we can capture and use in our customer identity graph? Now, this may be a little bit of a non sequitur, but even when we're using large language models, we still have corporate knowledge and corporate language that we have to care about. I didn't talk much about large language models yet, but the point is that with an LLM, it already has knowledge of relationships of terminology and language and concepts. And there are generalized language models, and then there are specialized language models. And we heard a little bit about that in some of the earlier sessions. And even those industry-specific language models can sometimes be too big or too bulky or have terms that are not relevant. So for a pharmaceutical company, there was a language model they were using that had, animal diseases. Well, they didn't care about animal diseases. You might have an animal model of a disease, but they didn't treat animal diseases. So we have to take into consideration the enterprise ontology, the enterprise knowledge. Now, there's a difference between large language model and language model. A lot of times language models are used to do things like entity extraction, right? And looking at relationships between terminology, looking at synonyms and thesaurus terms, non-preferred terms, code names, all those types of things, or things that are conceptually related. That's our ontology. That becomes a graph, but it's different than a large language model. A large language model does have kind of an implied or derived ontology, but it really has many, many, many more relationships, because we represent content in a language model, in a large language model, in a vector space. And a vector space has as many parameters of that of a piece of content or a piece of language as there are characteristics. So it's n-dimensional. We only can think in 3 dimensions, 4 if we add time. But the idea of large language models is they put things into a vector space that has n dimensions, meaning all of the possible descriptors and facets that you could apply to content. And all of the, and the reason why they're large language models, they have other parameters such as weightings, numbers of layers of the neural network, and so on. So again, I want to make a distinction between a corporate ontology and a language model and a large language model. Those are really different things, because we have to fine tune. A large language model is not going to know the language of your organization. Now, along the lines of search is retrieval augmented generation. So I just talked about search. Well, one of the things that we find with large language models is they don't necessarily tell you how they get the answer, right? You're depending on the language model to, and some of these slides were cut, but I'll explain them to you. Some of the mechanisms for how the language model gets to the result are not readily visible, right? Because It's using its knowledge of language that it's learned from ingesting content and data from the internet to answer a question. It's making a prediction about what words are likely to appear after this. It's actually comparing vector spaces. You're ingesting your question into a vector space, and you're comparing it to the vector space of other language and other phrases and other terminology, and you're comparing those. And there's a lot of other mechanisms. That's a gross oversimplification, but it's hard to determine how it's making its giving you its answer. It doesn't tell you how it's happening, and it doesn't understand non-public information like your policies, your procedures, your processes, your transactions, your competitive intellectual property. Right? You can't have it know your intellectual property because that's your competitive advantage. So the standardization by using a large language model to do certain things is great for efficiency, but we need differentiation to give us competitive advantage. Guess where differentiation comes from? It comes from your knowledge graphs, because your knowledge graphs contain your knowledge, your data, your information, your content, your organizing principles, your language, and that has to be leveraged by a large language model based application. So how do we do this? We don't know. We also need to determine whether a piece of an output is fabricated and not acceptable, or creative, which is acceptable, right? What's fabricated, what's creative? Well, there's ways to do this. And one of the things we do is we turn the temperature variable down in a large language model to 0. It goes 0 to 1. 1 is more creative, 0 is less creative. And then we point to a specific piece of content, right? We point to a specific data source, and we search that data source and retrieve it, retrieve the content, and we use those signals that I just showed you to inform the large language model, to enrich the embeddings. When we import our content into an LLM, into a vector space, we actually add metadata to it, and we use that to enrich the embeddings. That metadata becomes additional signals for the language model to be able to retrieve a result. So again, when we start looking at this, it understands concepts and terms and relationships based on generalized language. They can be tuned to more specialized language or topics in, say, technical domains with your technical content, your particular competitive IP. And it needs to be, whether it's generalized or specialized, it still needs to be augmented with the enterprise-specific terminology that comes from the knowledge graph. So the knowledge graph is critical to having LLMs perform as they should. And again, it's not necessarily retraining the model, right? Because that can be costly. It's using retrieval augmented generation. And I have a very quick animation on that. But content management and knowledge management is needed to make sure that it has the information. If it doesn't have the information, it'll make it up. But you can also, with retrieval augmented generation, tell the model, if you don't have the answer from this information source, say, I don't know. That, with the temperature turned down to 0, will virtually eliminate your hallucinations. We need to make sure we have the knowledge and expertise for it to function. We need to design the knowledge base that we're retrieving from using retrieval augmented generation, right? Again, it's not using the language model to answer the question. It's using the language model to process the query, and then you're retrieving the information. So you're still doing the same thing with the query, just like you would classify utterances into an intent, right? I can't change my password. I'm locked out of my computer. I forgot my username. My computer's mad at me. Those all resolve to the same intent of change password. The same thing happens on steroids in a large language model. You're normalizing the query. You're normalizing the prompt, and then you're using that to retrieve from your knowledge base. Could use a vector similarity search, or you could use semantic search, and then you're normalizing and making that answer more conversational at the output. So it's really important to have that information architecture and that knowledge graph, and using that knowledge graph as reference data for the large language model and for your content. And this can have a very significant impact. And I'll just very quickly finish with a quick case study. This is a pharmaceutical company. We had a portfolio review application, highly sensitive information. This is all their drugs in development, companies they want to purchase, clinical trial results, right? Number one, you cannot let that out into the public, right? It's very confidential. Number two, you can't have hallucinations. And so what we did was we actually tested the value of information architecture on the large language model response. And here's how we did it. We componentized the content. We enriched that content with metadata from the knowledge graph. We ingested that into the vector space. And again, the metadata becomes additional signals for the LLM. Then we process the retrieved results with the large language model. Then we present the results. And this is what happened. Without the metadata, it was 53% accurate, 53% of the time. With the metadata, it was 83% accurate. So it had a huge effect on it. And many times it would choose from the metadata itself or choose from the content. It didn't matter. That's invisible to the user. But the information architecture and well-designed use cases, these are narrow use cases, allowed us to do this side-by-side comparison and show the value of essentially an ontology and a knowledge graph on the results of a large language model. They were more complete and more accurate with the ontology, with the knowledge graph, with the information architecture, and many of the questions couldn't be answered without the information architecture. So to summarize, knowledge graphs don't fix the problems or organization design or bad data. They require upfront work, even when you can start to derive things automatically from existing data sets. You still need human judgment. The knowledge graph provides a reference architecture and context for any type of cognitive application, any type of AI or machine learning application, as well as traditional decision-making frameworks. And they're at the core of personalization and contextualization. I didn't show how the knowledge graph is used for content, but you guys know that. You need to tag content from a knowledge graph. And again, it's a great iteration of data integration. It has all these wonderful capabilities, but it's not magic, right? We still need human judgment. With that, I'm going to finish the talk. By the way, we do a little CAM and AI readiness assessment. You can take a look at that. I did want to have a URL for my book, but send me a note if you'd like a copy of my book. It's called The AI Powered Enterprise, and it's been well received. And it was written in 2020, but it still completely applies today. I mean, I thought my work was over when I first saw ChatGPT, and then the more research I did, the more I realized it was more important than ever. Anyway, thank you for your time, and I think we might have a time for a question.
Yes, thank you so much, Seth. That was amazing. We do have one question in the chat right now from Frank that says, is there any standard way to connect knowledge graphs with LLMs?
There's a lot of ways to connect knowledge graphs with LLMs. I mean, it's really something when you think about the different possibilities. There's some great stuff on Medium, and a guy named, I think, Tomaz, Tomaz or Thomaz, Barzak, something along those lines. He's done some wonderful stuff. I can also get you, if you send me a note, I can also get you, I have a whole spreadsheet of knowledge graph related tutorials and references and articles. And if you send me a note, I will send that to you. That's like a compilation over the last several months. So there's no standard way to do it. It really, and that's stuff we're working on a course right now using Ontotext and actually Pool Party. Surprise to both of them because I haven't told them yet, but I love the stuff I saw today with the combination of those tools. And we're working on that to actually build templates and methodologies to do that in a standard way, because it's also very, very new. I wish I had a better answer for you. But send me a note, seth@early.com, and I'll get you that spreadsheet.
Great. And yeah, we probably have time for one more, Seth. Can you talk a little bit more about the opportunity for personalization with generative AI and how that works?
Sure. So again, it comes back to the more you can tell the large language model about your question or your prompt, the more it can give you a better answer, a more specific answer. And so when you look at the search example, I was taking those signals about the user. And so ingesting and using that to reference, provide additional search signals to the search engine to say, because when you think about it, you have to take your content and tag it in such a way that it does have an understanding of who it's for. The same thing has to happen with knowledge graphs. I mean, with large language models. We need a mechanism to tell the large language model who you are and said, I am a this, or I am that, or it will inherit or import based on your identity graph information about the query. So it's contextualizing the query even behind the scenes with your metadata, with the things that represent, and sorry, I just hit my microphone, with the things that represent your personal characteristics, your level of expertise, the equipment that you own, the specific problem that you're having, all of those things. And it will use those signals to match more effectively with content that it is generating, and again, that is retrieving. So it's the same idea of any personalization. Remember, what you're doing here is you're doing a query. You're doing a semantic search or a vector similarity search or a metadata search against content. Anytime you would do search, and that's why I showed the search example, and you would use signals about the individual, their identity graph, to inform that search, you're using the same thing for a large language model. Remember, you're retrieving from your data source. And the more signals you can provide your search engine with the characteristics of your context, are you a beginner? Are you an expert? Are you a specialist in the field, right? Those answers are going to be very dependent upon your background and your context. And your context is defined by your customer identity graph or your employee identity graph. What are your interests? What are your products? Are you an executive? Are you a technical person? Are you a deep technologist? Are you a data engineer? Are you a business user? All of those things will inform what we retrieve from our knowledge source. And then that is being processed by the LLM. So it's giving additional signals for the retrieval. And again, there are different ways, and there's many ways. There are probably many ways that I don't know yet about how a large language model could directly leverage that. But I'm looking at this as a retrieval augmented generation, where we're using those signals about the user to retrieve the right information. Then we're processing with a knowledge graph. And Forrester said retrieval augmented generation is going to have the single largest impact on any enterprise of any artificial intelligence or machine learning application. It is the future. RAG is the future.
Great. Thank you so much, Seth. We're running a few minutes over now, so thanks for answering that. If there are any other questions, please go to Early Information Science booth and drop them in there. But thanks again, Seth, so much. We really appreciate it.
Thank you for your time. I appreciate the opportunity. I appreciate your attention. So please reach out. Thank you. And connect on LinkedIn.